Okay, let's go.
Okay, we are back for the demonstration for the project in cloud computing services. We are in the AWS console, and we can see these are the services, some of the services in AWS, and then we look into the implementation of the project itself. Okay, so referring back to the architecture diagram, right? All these components makes up the website to make it reliable and scalable. So so that it will minimize downtime and it can cater to rising and decreasing traffic for our website. Okay, so without further ado, let's move on. So we'll be covering on the networking and security part of it. Okay, so the first part we go into the VPC, which is the virtual private cloud. This is where the VPC has already been created to house all the 4 subnets, 2 public subnets and 2 private subnets. Then the path that using the private and public cloud. Okay, and then another one more thing that is important also that we can after that is this is the facility in particular where we are already created a security group for the web server security group, and then open port for the TCP, and then this web server security group will be attached to the web server itself and the load balancer. Okay, so in the configuration, right, I actually use the web server security group for both the web server and the load balancer. But if I want to make it more, I can, because the configuration I open port 80 for source coming from 0.0.0/0, that means from the internet. So I can actually create another security group for the web server in the instance to open port 80 for only the security group that is housing my load balancer. That means the port 80 will only be open to traffic coming from the load balancer and won't be open for other places and other sources. So that will be more secure. So this security group is then attached to the EC2 instance that we created. And then as you can see here, these are the 2 desired EC2 instance spin up by Auto Scaling Group. Although I've already deleted the first EC2 instance that I created for the template. So basically to briefly inform of how I created the template, I created a web server instance using the Amazon Linux OS and using the user data to actually the website content. This is the user data I mentioned previously, install the HTTP and download the content of the website and then move the content website to the path to the website. So all of that will be cleaned up when I clean up the instance. Okay, after doing that, I created the image from the HTTP instance created. So I have an image template that I can use. So having that, I can create a template for the post that you use later on. Okay, to have a clearer picture, this is the flow. I created a web server, and then for the web server, with the unit, I created the image from it, and then it will be used as a launch template. And I created a launch template which uses the image, so that the auto scaling group, when spinning up EC2 instances, it will follow the template of the image I used before that I created. Okay, so the next part, we go into the load balancer and the target group. So the load balancer requires us to create the target group in order for us to use the load balancer, because it will distribute the traffic in between the target group, content of target group. So basically, if we have a few instances in the target group, we will distribute in between this. Let's say for this example is 3, but for our project will be the 2 instances that we are running. Okay, so we can see from here the load balancer. The load balancer has is a listen. We already configured the listener to forward to the target group. That means it will be the traffic that pass through the load balancer will go to the target group, which is the web server inside the target group. Okay, and then we've configured for the load balancer to load balance in between both the 2 AZ, US East 1A and US East 1B, which is our private subnet. This is the availability zone for the load balancer, which is housed in the public subnet. Okay, we can check that. Okay. Yeah, so 69E. Okay, yeah, is the public. So because our load balancer is public facing, so it is in the public subnet. Okay. Among the other things, the listener is listening to port 80 to the web servers in the target group to check whether it's healthy or unhealthy. If it's unhealthy, that means it's uncontactable. There could be many reasons that it will be unhealthy. And then other things also, the load balancer, as mentioned, is using the same security group. You can do the monitoring here, whether we receive errors and what are the response. And then so we will look more in depth into the target group itself. The target group is we have in the target group now is the auto scaling group that spin up 2 instances that are running at all time, and then it's showing both the instances are healthy. And then notice both are in different AZ as explained in the architecture to provide the HA redundancy. Okay, so that's basically the relationship between load balancer and the target group. And then we move on to the auto scaling group. The auto scaling group, we have configured a target tracking policy, which will monitor the CPU utilization of the web server to reach its threshold of 50%. Once it reach more than the threshold, it will spin up it will scale out for more EC2 instance to be spin up. So once both of the web server have this utilization threshold more than it, and then it will spin up more to actually to make the traffic more distributed within all the instances. Okay, we'll see more into the auto scaling group configuration. Okay, before going to the auto scaling group configuration, just to show you also, this is the launch template that we have created from the AMI image mentioned previously. So you can see we have all the same specs, and using the security group also configured with the web server security group. And then so that it will every time it will spin up the same EC2 instance with the same user data, and then we will have minimum downtime as we are displaying the same website seamlessly. So the user from the other end on the browser will only see the website is the same all the time. Okay, so moving on, the template was used in the auto scaling group. You can see the details. We have already configured. These are the values that we have set for the auto scaling. It will scale into our desired capacity of 2 instances at all time, and then minimum capacity of instances running should be 2 also that we've configured. So it won't go decreasing the number of instances to become 1 instance running at one time. And then when the traffic goes higher, the maximum is to spin up to 6 instances at one time. So it won't, although the traffic goes higher and higher and higher, it won't go more than 6 instances at one time. So we have explained briefly about the implementation. Let's see a demonstration of how the website will look like. Okay, for that we'll be going to the load balancer and taking the DNS name and paste into our browser. Okay. Oops, wrong spelling. Okay, now we are looking at the website with our content. Okay, so basically this website will load the EC2 to 100%, and then we will see how the auto scaling works. Okay, so once we click on this, it will go to 100%. Okay, now the CPU load is 100%. It will rise up the CPU load, and then we will see how it goes.
Okay, let's go.
Okay, we can see here that the CPU utilization of the EC2 instance rise up high from 50%, from minimum utilization up to 50%, and then goes up to 100% instantly because we use the load test from the website. Hence, it's rising up. So after a while, I've paused the video already, and then and see here that it's reflecting in the activity history that the monitor alarm has been triggered, and then the desired capacity changed from 2 to 4 as the traffic is detected the load requires higher capacity to cater to the traffic, and then it's recording the activity, and then you can see it's already spin up another 2. Now the number of EC2 instances running is 4, so basically 2 more is initializing now to cater for the load that we have run through because of the website. Now that it has detected the load requires more, because it's a dynamic scaling, So it will edit our desired capacity from 2 to become 4, but still adhering to the maximum capacity.
Okay, now it's reflecting in the target group as well. Now it's targeting for these 4 instances. The load balancer is distributing traffic in between these 4 instances of our web server. We can see here it's spinning up. It's spin up in there another 2. So now our total is 6 already. And then if we see the automatic scaling here, the detail here, if we refresh here, the desired capacity becomes 6 already. So now we have 6 instances, auto scale and load balance, but load balance by the application load balancer.
So okay, we look into the scaling out. So how about when the traffic goes down and then it's scaling back? So as this is not the real time situation, we try to simulate a real time situation. Okay, so we close this website that actually will load the CPU, and then to simulate it, we'll in a way we'll force the desired state instead of 4 instance to go to 2 instance. So in a real world scenario where actually the traffic goes down, so it will scale in back to the desired state of 2 instances. We will observe how it goes. Okay, we can see here that it is draining the other 4 instances as desired only is 2. So it will drain out the other 4 instances, and then we'll see it spinning in into the desired state of 2 instances only. So basically, when we force the desired state to become lower than the dynamically edited desired state, which was has gone up to 6 when the load was at their peak, we force the auto scaling to scale in and drain out all the extra instances and leave us with the two desired instances that we want. This is to simulate how the CPU load or the traffic when the traffic goes down, and then the CPU and then when the auto scaling group scale in our web server instances to cater towards lower traffic and lower load of CPU. So once the draining is completed, we will end up with the desired state of 2 instances as per normal and stabilized. Okay, I think that's all for the demonstration. Thank you so much.